All right, welcome back to another video. So this is going to be part of the series where I prepare for my fantastic new opportunity that I will be embarking upon 5/25 of this month, so May 25th. So I got about a month to do whatever I need to do to make sure on day one I can be the best I can be. And in my opinion, that is learning network automation. So I've already, of course, got quite a bit of experience in network automation, a number of projects I did at my old position, and of course, currently now as we speak, but not at the time this video goes live. I am working as a network developer. I'll be switching over to a senior network engineer role, but it will be a role where network automation is very important. Even though it's not explicitly a network developer title. All right, so let's continue where we left off. The book actually gave us this link to this great website. This looks like a similar website that the creator of Nmap runs. Unfortunately, the link's broken, but it's pretty obvious what it's meant to be. So to get a useful page, this page is kind of a bit useful, a bit useless to somebody who wants to just read the content in the book. You got to click read the guide online free over here, and then the most useful part I think is clicking this contents icon, and now you get the whole table of contents. So we want to learn about the push flag. Aha, so we know exactly what the push function of TCP is if we were to read this section. But I'm going to forego that for now because it's not going to be immediately relevant. More relevant is just getting through this book. I'm hoping maybe even I can have the whole thing right on Sunday. That would be fantastic, because a month might seem like a lot of time, and well, it's not even a full month. I start on the 25th, but believe me, time moves faster than you would expect at sometimes. The user data protocol, the user datagram protocol. This is UDP, the connectionless layer 4 data transfer protocol. This is user data protocol, this is UDP, which stands for user datagram protocol. The UDP is also the UDP, user datagram protocol, it's a protocol, like BGP is a protocol, is also a core member of the Internet Protocol Suite. Like TCP, which stands for Transmission Control Protocol, it's also a protocol. Like UDP is a protocol, TCP is a protocol, ISIS is a protocol, OSPF is a protocol. I don't know if ISIS is a protocol, actually. It's unclear to me what exactly is and is not a protocol sometimes. Like TCP, it operates on layer 4 of the OSI model that is responsible for delivering data segments between the application and the IP layer. Unlike TCP, the header is only 64 bits, which only consists of a source and destination port, length, and checksum. The lightweight header makes it ideal for applications that prefer faster data delivery without setting up the session between two hosts or needing reliable data delivery. Perhaps it's hard to imagine with today's fast internet connections, but the extra header made a big difference to the speed of transmission in the early days of X.21 and frame relay links. Besides the speed difference, not having to maintain various states such as TCP, Transmission Control Protocol, also saves computer resources on the two endpoints. So you can see here, yep, here's the UDP header. All we've got is, so here's octet 0, bit 0, So here's the bits. So the first octet and the second octet are going to be the source port. Then we got the destination port, length, and checksum. So we've only got 4 things in the UDP header, making it only 64 bits long. Whereas the number of things we have in the TCP header, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19 things in the TCP header. And you know, some of them are flags. They're not all going to be toggled on. They're of course, what you define as a thing could be kind of arguable, so that I forget what it was, 17 or 18. Let me count it up again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you could say that, oh, we only have instead of 19, we have 10 things, because flags are a thing, but individual flags are not things of themselves. But I'm definitely comfortable enough saying that there are 19 things that make up TCP, but the number of things that make up UDP are just 4. So you can see very clearly what the difference is between TCP and UDP. UDP, you have that tiny header, 4 things amounting to 64 bits. So the advantage is when you're packing your suitcase, you don't have to include your hairdryer, you don't have to include your fancy shoes, you don't have to include 3 towels. You know, you can just rely on the hotel to have a towel. You can just have a pocket comb and then just go with that. And you can just bring 1 pair of shoes with you. But of course, you know, your hair might look terrible. The towel might not, the hotel might not have a towel, or there's some problem with the towels. And you might step in something and not be able to change your shoes, or the function you're going to, you could look really inappropriate wearing sneakers at a business conference. So it's kind of a similar thing. Yes, you can pack a smaller suitcase, but you know, not having those 19 things and only having and having 15 fewer things, you know, comes with a trade-off as well. But yeah, like the difference between a 160 bit header and a 64-bit header. I mean, that 64-bit header is more than, the 160-bit header is more than twice as large as the 64-bit header. If you multiply that by 2, you've got 128, and then if you add that up again, you've got 192. So it's kind of between 2 and 3 times larger than the UDP header. So it definitely is large enough to be a considerable trade-off, and something where applications like voice, video, where latency is a huge concern, you don't want to have to wait for any of your traffic. Yeah, you might want to go with UDP, because if you drop a packet here and then, you can just say, oh, what did you say? The traffic dropped. But if it takes, you know, 10 seconds for somebody to reply to you, how can you have a conversation like that? It's much better to have less in your suitcase and then prepare for any situations you might arrive in some cases than it is to have more packed with you. But of course, have to check your bag with the TSA, take longer on the TSA screen, and just end up not needing anything, have to stuff it in the overhead compartment. You know, having more things with you can be an advantage and a disadvantage. So You might now wonder why UDP was ever used at all in the modern age. Given the lack of reliable transmissions, wouldn't we want all connections to be reliable and error-free? If you think about multimedia video streaming or Skype calling, those applications benefit from a lighter header when the application just wants to deliver the datagram as quickly as possible. You can also consider the fast domain name system DNS lookup process based on the UDP protocol, where the trade-off between accuracy and latency usually tips to the side of latency. Yeah, so that's a really good example too. DNS, you know, does it really matter? It doesn't matter as much that you get it right the first time. They can send it again and get it again. It just matters that you eventually get it, and you want it as fast as you possibly can get it, even if that means asking for it multiple times. Something like a file transfer, though, you know, you want to make sure every byte in your file came through uncorrupted, and when you actually install that on your computer, you're installing the file exactly as it was sent, and you have absolutely nothing missing from that file. So FTP, file transfer protocol, is a good example of something that is, well, actually that might be its own protocol too. But SSH is a good example, because that, you know, it's important that all the commands you send to a device are received and processed correctly. Accuracy is much more important than latency. You can handle a little bit extra time to configure a device as long as you know that your configuration is going to be implemented as you intended them to be. So that SSH definitely rides on top of TCP, BGP rides on top of TCP. There are a lot of protocols where that accuracy is of paramount importance. And then of course there are protocols like DNS, anything for video streaming, Skype calling, where it's okay if you lose a few packets, you just ask it again, or you just have a little blip where it's, oh, what'd you say? Oh, okay, that's fine. Or, oh, my thing cut out for a while. You know, that's totally fine as long as you can have a real-time communication with someone. That's not as that's not as possible when you use TCP. Although from what I understand, like modern networking equipment, modern computers and stuff, you can have a connection with somebody over TCP that's pretty much the same as UDP. I mean, 160 bits, like the amount of cache space and buffer space on most computers nowadays, like, you know, the difference between 64 bits and 128 bits, or sorry, 160 bits is basically no difference. I mean, we're talking about bits. We were talking about 60 bits versus 160 bytes. Yeah, there might be some issues there, but really that is such a, but of course you got to remember too, this is per packet. So if we're streaming a movie, we're going to have, you know, millions of packets going through. Each of them is going to have that header, if you're using TCP, that is about 2.5 times bigger than what you would get if you were using UDP. So yeah, in an individual packet sense, it might not seem like a huge trade-off, but we're talking about floods and floods of traffic, which will definitely add up. So, all right, let's just keep reading. You can consider the fast name. Yep. When the address you type in on the browser is translated into a computer understandable address, the user will benefit from a lightweight process, since this has to happen before even the first bit of information is delivered to you from your favorite website. Again, this section does not do justice to the topic of UDP, and the reader is encouraged to explore the topic through various resources. If you are interested in learning more about UDP, okay, so here's the Wikipedia article. This they say is a good starting point. So yeah, we can see what? Oh, okay. So it looks like this isn't necessarily about UDP. Although it says it is. I'm really surprised that BGP is on there, because we definitely know that BGP is not run on UDP. That's kind of one of the main oh, okay, I see. So this is a transport layer protocol. Then you have application layer protocols too. So a protocol doesn't mean the whole outfit, you know. A protocol, we're talking about, if we were talking about shirts and pants, as if they were protocols, we would call both a shirt and pants a protocol. But we would call pants a transport layer protocol, and we would call shirts an application layer protocol. So it's kind of a bad word, protocol. I really wish that word were used better. I kind of don't like how that word is used, but that kind of makes sense for me now. You've got to have a protocol on the transport layer and on the application layer. Looks like you also need protocols on the internet layer. We've got ICMP. That sounds like, I bet you that P stands for protocol. So protocol network. Yeah, I just want to read the definition from Technopedia, because the word protocol to me is used in a way that is a little bit problematic. What does network protocols mean? Network protocols are formal standards and policies comprised of rules, procedures, and formats to define communication between two or more devices over a network. They ensure that computer network devices can transmit and receive data using a common language regardless of their different designs, hardware, or infrastructures. Network protocols govern the end-to-end processes of timely, secure, and managed data or network communication. They can be built into hardware or software, and they're so important that in practice, every network used rely on network protocols for communications and connectivity. So yeah. Yep. Yeah, and then IP, internet protocol, that's a protocol as well. But just because you have one protocol doesn't necessarily mean you don't have another protocol, unless you're talking about protocols on the same layer. Yes, if you have TCP, you don't have UDP, but that's because those are transport layer protocols. Application layer protocols, if you have HTTP, you do not have HTTPS. If you have BGP, you do not have DHCP. If you have DNS, you do not have FTP. But if you have BGP, you do have TCP. If you have FTP, you have TCP. If you have DNS, you have UDP. If you have SSH, you have UDP. Yeah, I think I made the point. Oh, sorry, you have TCP. I mean, if you have SSH. And of course, you also have IP. So if you have BGP, you have TCP, and you have IP. So you've got 3 protocols in one. You've got a shirt, you've got pants, and you've got shoes, but they're all in the end just clothes. All right, the internet protocol. As network engineers will tell you, we live at the IP layer, which is layer 3 on the OSI model. IP has the job of addressing and routing between end nodes, among others. The addressing of an IP is probably its most important job. The address space is divided into two parts, the network and the host portion. The subnet mask is used to indicate which portion in the network address consists of the network and which portion is the host by matching the network portion with a 1 and the host portion with a 0. IPv4 expresses the address in the dotted notation, for example, 192.168.0.1. The subnet mask can either be in a dotted notation, 255.255.255.0. I used to have to, another kind of funny aside, I used to work to deliver devices to customers, but I would work hand in hand with NetTechs. They were, the smart hands, and I was the kind of guiding voice over the line. I would often have to tell them what to configure on the device, and I would say 255.255.255.0. And I'd have to say it. I couldn't just, I could say /24 to some of them, but kind of the way it was designed, we wanted those net techs to be anyone we can get. Like it was hard to get net techs. Of course, it's hard to get network engineers too. Like it's just a field where there's not a lot of people who know this stuff. I kind of learned after a while to say the subnet mask ends in .0 or the last octet or ending in. So then I didn't have to say 255.255.255.0. I'd say it's a /24 ending in .0, or it's a /25 ending in 128, or /26 ending in 192. The subnet mask can either be in dotted notation or use a / to express the number of bits that should be considered in the network portion bit /24. So that's called CIDR notation, CIDR. The IPv6 header, the next generation of the IP header of IPv4, has a fixed portion and various extension headers. So yeah, IPv6 kind of, they made a lot of improvements. They got rid of ARP. They made a new thing called neighbor solicitation. And then we can see kind of like UDP, it's a lot more simplified of a header format. So yeah, let's count up the things in a IPv4 header format. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 things. So fewer things than in a TCP header, but it's a much larger header. I wish it would say exactly how long. It looks like it's 256 plus 31 long, so it actually extends out to a third. Well, it should be 4. No, that's an IP address is 4 octets, but the IPv4 header is 256 plus 31, so 287. The IPv6 header is going to be 288 plus 31, so it's a little bigger, but let's see how many things it has. 1, 2, 3, 4, 5, 6, 7, 8. Only 8 things, so a lot more simplified. The IPv6 next header field in the fixed header section can indicate an extension header to be followed that carries additional information. It can also identify the upper layer protocols such as TCP and UDP. The extension headers can include routing and fragment information. As much as the protocol designer would like to move from IPv4 to IPv6, the internet today is still pretty much addressed with IPv4, with some of the service provider networks addressed with IPv6 internally. So yeah, this is an important distinction to make. There are a lot of people who are using IPv6. IPv6, is for the most part not too bad, but there are some things that are kind of a problem with it. The thing that's the most obvious and that I know about the most is it uses colons to be written out. So if we had just a pretend IPv6, so documentation prefix for IPv6 is 208. I think it's DB8 as well. I'm not sure, but you can see I've got to use colons to express that. So how do we write out a socket? Well, what is a socket? A socket is a IP address and a port. So it's a layer 3 on the OSI model IP, Internet Protocol, and then it's a layer 4 port number. So how would we write that right now? 192.168.1.1 colon, then the port number. So I can actually do this. It's a valid thing I can enter in my address bar. And it will actually know that I'm saying I want to go to a website, even though I have a colon in there, because I'm specifying the port. And in fact, those colons are usually implicit. This has a colon in it. All of these sites have a colon. So I'm going to do an F12 and look at the network tab on here, and I'll refresh this, and we'll see. And I'll click one of these, and we'll look at the header here. Yep. So see that colon there, colon 443. So that's called a socket, and it's a socket is just an IP address and the port. Well, now we've got IPv6. So how are we going to tell it, what port it belongs to? Because we can't use the colon anymore, because now we don't know if this is the full address. This is a valid IPv6 address right here. It could just be I have one fewer octet of zeros in that double colon. So we can't use the colon anymore. That's a problem with IPv6. So compatibility and all those kind of issues with IPv4 sockets is not as easy. And I'm no expert on this, but this is, if anyone's watching this and they want to kind of connect with their principal engineers or the smartest guy on the floor, just ask them what they think about IPv6 format, and if they think there's a better way that it could have been designed, because you'll get a lot of interesting opinions about what could have been implemented instead of IPv6. IPv6 network address translation, NAT, and network security. NAT, network address translation, is typically used for translating a range of private IPv4 addresses into publicly routable IPv4 addresses. But it can also mean a translation between IPv4 to IPv6, such as at a carrier edge when they use IPv6 inside of the network that needs to be translated to IPv4 when the packet leaves the network. Sometimes NAT6 to 6 is used as well for security reasons. Security is a continuous process that integrates all the aspects of networking, including automation and Python. This book aims to use Python to help you manage the network. Security will be addressed as part of the following chapters in the book, such as using Python to implement access lists, search for breaches in the log, and so on. We will also look at how we can use Python and other tools to gain visibility in the network, such as a geographic network topology dynamically based on network device information. IP routing concepts. IP routing is about having the intermediate devices between the two endpoints transmit the packets between them based on the IP header. For all communication via the internet, the packet will transverse through various intermediate devices. As mentioned, the intermediate devices consist of routers, switches, optical gears, and various other gears that do not examine beyond the network and transport layer. In a road trip analogy, you might travel in the United States from the city of San Diego in California to the city of Seattle in Washington. The IP source address is analogous to San Diego, and the destination IP address can be thought of as Seattle. On your road trip, you will stop by many different intermediate spots, such as Los Angeles, San Francisco, and Portland. These can be thought of as the intermediary routers and switches between the source and destination. Why was this important? In a way, this book is about managing and optimizing these intermediate devices. In the age of mega data centers that span the size of multiple American football fields, the need for efficient, agile, reliable, and cost-effective ways to manage the network becomes a major point of competitive advantage for companies. In future chapters, we will dive into how we can use Python programming to effectively manage a network. Now that we've taken a look at network reference models and protocol suites, we're ready to dive into the Python language itself. In this chapter, we'll begin with a broad overview of Python. So finally, we made it there. I'm glad to be done with that reading because none of it was new to me. I mean, it's always interesting to, as I said, refresh those fundamentals, because the fundamentals are called fundamentals for a reason. Really important you know them and you can talk about them and you're really comfortable with them. Kind of expanding on his analogy of if you're driving from San Diego to Seattle, there being with San Diego as your source address, Seattle as your destination address, and then along the way there being intermediate spots such as Los Angeles, San Francisco, and Portland. So if you're thinking of those cities as routers, switches are going to be the roads you take, kind of. It'll be like the exits you take. So you're going to have, when you go to, it's kind of hard. Yeah, I think the analogy kind of breaks down, but one thing this book didn't explain that is going to be a big part of networking as well is kind of clear or even a broad overview of switching instead of just IP routing, because switching, which is moving traffic around without an intermediate device, is a really big concept. And in fact, at my previous position, a big part of what we did was things that were done without those intermediate devices, because the span where you don't need an intermediate device, it is really, really big. Like those intermediate devices are literally, analogous to Los Angeles, San Francisco, and Portland. You drive through hours and hours of stretches of other things before you get to those major hubs. So switching definitely is a very big concept that unfortunately this book really didn't look at all. And unfortunately, I don't really know how to fit into their analogy of driving from San Diego to Seattle. All right, so Python language overview. In a nutshell, this book is about making our network engineering lives easier with Python. But what is Python and why is it the language of choice for many DevOps engineers? In the words of the Python Foundation Executive Summary, and again, I'm gonna have to say I'm pretty disappointed with this book. The title is Mastering Python Networking. If we're trying to master it, we don't need to know what Python is. We've used it, we're comfortable in it, we just want to master it. We want to get as good with it as we possibly can. So I'm really disappointed to see the question, what is Python, in a book that's meant to master the language. We know what Python is. The reason I purchased this book is because I want to master Python, and I believe I'm already at a pretty high level with it. Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Its high-level built-in data structure combined with dynamic typing and dynamic binding makes it very attractive for rapid application development, as well as for use as a scripting or glue language to connect existing components together. Python's simple, easy to learn syntax emphasizes readability and therefore reduces the cost of program maintenance. If you are somewhat new to programming, the object-oriented dynamic semantics mentioned previously probably do not mean much to you, but I think we can all agree that rapid application, that rapid development and simple, easy to learn syntax sounds like a good thing. Python as an interpreted language means that there is little to no compilation process required before execution. So the time to write, test, and edit Python programs is greatly reduced. For simple scripts, if your script fails, a print statement is usually all you need to debug what was going on. And of course, there's a trade-off with that. Languages where you do have to compile it and doesn't just compile it on the fly run a lot faster than languages like Python after it's already compiled. Using the interpreter also means that Python is easily ported to different types of operating systems, such as Windows and Linux, and a Python program written on one operating system can be used on another with little to no change. The functions, modules, and packages encourages code reuse by breaking a large program into simple reusable pieces. The object-oriented nature of Python takes it one step further for grouping the components into objects. In fact, all Python files are modules that can be reused or imported into another Python program. This makes it easy to share programs between engineers and encourages code reuse. Python also has a batteries included mantra, which means that for common tasks, you need not download any additional packages outside of the Python language itself. In order to achieve this goal without the code being too bloated, a set of Python modules, aka standard libraries, are installed when you install the Python interpreter. For common tasks, such as regular expressions, mathematical functions, and JSON decoding, all you need is the import statement and the interpreter will move these functions into your program. This batteries included mantra is what I would consider one of the killer features of the Python language. And I definitely agree with that. I mean, imagine having to write yourself a program to do regular expressions, like just using that actual, if it's already written and coming up with the correct regular expression to use is difficult itself. Like imagine having to write the actual thing that can like actually search through. And yeah, this is what I like about Python too. If somebody has already done really difficult, brilliant work, I would rather just respect the work they did and gratefully use it than try to redo something that somebody way smarter than me has already done. Lastly, the fact that Python code can start in a relatively small-sized script with a few lines of code and grow into a full production system is very handy for network engineers. As many of us know, I got a cramp. That's what I'm saying ow about. I'm getting a cramp in my foot. As many of us know, the network typically grows organically without a master plan. A language that can grow with your network in size is invaluable. You might be surprised to see a language that was deemed as a scripting language by many is being used for full production systems by many cutting-edge companies, organizations using Python. So yeah, lots of big organizations. Reddit is all on Python. Google, yeah, lots of Python in Google. Some big ones. Lots of games written in Python. This is interesting. Is this the VR game? I don't know. So lots of Python is used for a lot of science stuff too. It's really good for data analysis and things to do with data. Yeah, so lots of educational uses. So yeah, lots of Python is not, and this is a way you can combat, as I said, if you're not in that unicorn environment where everyone kind of understands what you're trying to do when you're trying to automate something. And this is where you can handle people being perhaps a bit antagonistic towards you trying to use something like Python to automate tasks. You can say, well, look at all the other organizations that are using this. Are you saying you don't want our organization to be as successful as Google? So if you have ever worked in an environment where you have to switch between working on different vendor platforms, such as Cisco iOS and Juniper Junos, you know how painful it is to switch between syntaxes and usage when trying to achieve the same task. Since Python is flexible enough for both small and large programs, there is no such dramatic context switching. It is just the same Python code from small to large. I want to read that again. If you've ever worked in an environment where you have to switch between working on different vendor platforms, such as Cisco iOS, Juniper, yeah, I know that, yep. You know how painful it is to switch between syntaxes. Yeah, you know what? I do know how painful that is. And usage when trying to achieve the same task. I agree, it's painful. Since Python is flexible enough for both small and large programs, there is no such dramatic context switching. It is just the same Python code from large to small, and that's wonderful. Python, you can use it for whatever you want to use it for. Wonderful. For the rest of the chapter, we will take a high-level tour of the Python language. For a bit of a refresher, if you are already familiar with the basics, feel free to quickly scan through it or skip the rest of the chapter. So I'm going to go forward with it. I am familiar with the basics, but I want to basically, if there's anything valuable in this book, I want to take full advantage of it before I start on the 25th. So I'm kind of going to be biased towards doing more than doing less. But here's my Python interpreter. It's IPython, so it's going to be different. All right, Python versions. Many readers are already aware Python has been going through a transition from Python 2 to Python 3 for the last few years. Python 3 was released back in 2008, over 10 years ago. So this is a fairly recent book, it's about 2 years old, with active development with the most recent release 3.7. Unfortunately, Python 3 is not backward compatible with Python 2. At the time of writing the third edition of this book in late 2019, okay, so it's more recent than I thought, the Python community has largely moved over to Python 3. In fact, Python 2 will officially be end of life beginning January 1st, 2020. And let's look at the Python clock. It should have expired already. Yeah, it expired. The latest Python 2.x release 2.7 was released over 6 years ago in mid-2010. Fortunately, both versions can coexist on the same machine. Given that Python 2 is end of life and not maintained by the time you read this passage, we should all switch to Python 3. More information is given in the next section about invoking the Python interpreter, but here is an example of invoking Python 2 and Python 3 on an Ubuntu Linux machine. So I am running a Windows 10 machine, but it is going to be a bit similar, but for the most part, pretty frustratingly different. This is, yeah, if you're a Windows user, it can get really upsetting at times to Google for help with things like Python, because it's just all different, and it's all worse too. It's not as good as Linux and even Mac. So you often won't get help in it because people just, if they have the option to not have Windows as their development environment, which most advanced developers do, they will just not choose it. So if you're asking for advanced advice, you're asking for somebody who's using Linux. So it's kind of a bit of a problem. Me, I'm at I think a fairly good level. I just muscled through it with Windows 10. I figured out. So you can see Windows 10 equivalent for those commands there. It's going to be pi space dash 2, and I've got 2.7 dot 17, and then pi dash 3, or since it's set up to pi by default, for me is Python version 3. It's just pi, or you can do space dash 3. And I've got version 3.7.4, so the same version that's in this book. With the 2.7 release being end of life, most Python frameworks now support Python 3. Python 3 also has lots of good features, such as asynchronous I/O, input-output, that can be taken advantage of when we need to optimize our code. This book will use Python 3 for its code examples unless otherwise stated. We will also try to point out the Python 2 and Python 3 differences when applicable, which I kind of wish they wouldn't do, because I don't care really. I'm just going to use Python 3. I don't really want to use Python for anything so complicated that the differences would matter. If a particular library or framework is better suited for Python 2, such as Ansible, see the following information, it will be pointed out. Okay, well, that's nice. And we will use Python 2 instead. We should aim at using Python 3 as the default option and only use Python 2 when it is absolutely necessary. But we can see, at least on my machine, it's going to be different based on how you set up your own environment, assuming you have the luxury of doing that. As I said, previous videos, you might be handed a company PC that's just locked down and you can't set it up the way you would like. But it's just a difference of -2, -3 on mine. If we got to use Python 2, that's not going to be a deal breaker. At the time of writing, Ansible 2.8 and above have support for Python 3. Prior to 2.5, Python 3 support was considered a tech preview. Given the relatively new supportability, many of the community modules are still in the process of migrating to Python 3. For more information on Ansible and Python 3, please see that guide. We'll just skip that for now. Operating system, as mentioned, Python is cross-platform. Python programs can be run on Windows, Mac, and Linux. In reality, certain care needs to be taken when you need to ensure cross-platform compatibility, such as taking care of the subtle differences between backslashes in Windows file names and activating a virtual environment on different platforms. Since this book is for DevOps systems and network engineers, Linux is the preferred platform for the intended audience, especially in production. The code in this book will be tested on a Linux Ubuntu 18.04 LTS machine. I will try to make my best I will also try my best to make sure the code runs the same on the Windows and the Mac OS platform. If you are interested in the OS details, they are as follows. So this is one way I could go with this video. I could use my GNS server to, or not even GNS, I could just spin up a virtual box. But yeah, I could use my GNS server too, and just spin up a Linux network -dev Ubuntu box, just like he's got here. But I'm just going to try it on my local computer. Running a Python program. Python programs are executed by an interpreter, which means the code is fed through this interpreter to be executed by the underlying operating system, and results are displayed. There are several different implementations of the interpreter by the Python development community, such as IronPython and Jython. In this book, we will use the most common Python interpreter shell in use today, CPython. Whenever we mention Python in this book, we are referring to CPython unless otherwise indicated. One way you can use Python is by taking advantage of the interactive prompt. This is useful when you want to quickly test a piece of code, Python code or concept without writing a whole program. And this, do not shy away from doing this. This is the main advantage you get with Python. If you ever work with anyone who shies away from taking advantage of that interactive prompt, you might be in that situation I described where you're working for a ditch digging company where they don't want you to use a shovel for some reason. So what do? You, I don't know. You do whatever allows you to accomplish your ultimate goals. This is typically done by simply typing in the Python keyword, but of course, it's done that way on the Ubuntu. On mine, being a Windows 10 environment, I can't type out the full word, I just type PY. All right, so let's print out the hello world, which again, I will say I'm kind of disappointed in this book for taking such a low-level view towards this. I'm really here to master Python networking, not to learn it for the first time. Okay. In Python 3, the print statement is a function, therefore it requires parentheses. In Python 2, you can omit the parentheses. Yeah, one thing that's kind of nice is you get a warning for that if you omit it in Python 3. Because I learned a lot of my Python in Python 2. So I'm starting to get better now, but there definitely still are moments where I will accidentally type it out without parentheses. But you get a nice warning, because if I didn't have that, I would lose, I'm sure, a lot of time to just being like, oh, why the heck didn't work, until realizing, oh, I'm in Python 3. The interactive mode is one of Python's most useful features. In the interactive shell, you can type any valid statement or sequence of statements and immediately get a result back. Yes. I typically use this to explore a feature or library that I am not familiar with. The interactive mode can also be used for more complex tasks, such as experimenting with data structure behaviors, for example, mutable versus immutable data types. Talk about instant gratification. On Windows, if you do not get a Python shell prompt back, you might not have the program in your system search path. Yep, that's a very common problem. The latest Windows Python installation program provides a checkbox for adding Python to your system path. Make sure that it is checked during installation, or you can add the program in the path manually by going to environment settings. And I've had all sorts of problems with that. Like even going to environment settings has been a nightmare. A more common way to run the Python program, however, is to save your Python file and run it via the interpreter shell after. This will save you from typing in the same statements over and over again, like you have to do in the interactive shell. Python files are just regular text files that are typically saved with the .py extension. In the X world, so that's kind of any distro of Unix, Linux you're using, or Unix perhaps. You can also add the shebang, which is £, exclamation point, line on top to specify the interpreter that will be used to run the file. The pound character can be used to specify comments that will not be executed by the interpreter. The following file, helloworld.py, has the following statements. Okay, so let's do that. So I'd love to use Vi, but as I said, I don't have Vi because I'm on here. This might be my reason to switch over to that Linux VM, but what? Okay, so big problem here. They're saying that that you can let's see here, don't save. So can I do this at least? Can I do literally anything on Windows? I can play Microsoft games. Let's see here. So Notepad, hello world. I did Python instead of Notepad. I want to do Notepad. I don't even have my keyboard shortcuts on this Windows development environment. Let's do Notepad, hello world.py. Yep, and we're going to make a new file. Now we're going to try to copy paste, which is not going to work because it's a Windows environment. Yeah, and you can see just how bad of an example this is. I kind of don't know about this book. You know, as I've said multiple times, I kind of want to switch over. It's starting to get to be the point where I don't know how much this book is really going to be able to do for me. And you can see it's got a pretty serious error. It's including this print hello statement in the line that has been commented out. And then it's telling you that it's going to still be executed, even though that whole line has been commented out. So if you're learning Python for the first time, as this book seems to assume you're doing, even though it's titled Mastering Python Networking and not learning it for the first time, unfortunately, this would really confuse you, and you'd get a really poor sense of how comments worked. And you might even think that if you included an actual function, it would run even though the line it's on were commented out. So yeah, I think I'm going to take a tick. I'm going to do a 3 strikes you're out on this book. And if it gets 3 strikes, it's out. I'm moving on. I'm done reading it. I'm going to go to a different book. So it's got a strike. It's definitely got a strike. One thing I don't like about it is it assumes the unicorn environment that you'd be lucky to have. It's got a pretty serious error right there. The title is a lie. It's not about mastering Python networking. It's about learning for the first time. And there was another error. Oh yeah, they flipped 2 words. So this is the version 3, and they still can't get the grammar right. So that's an X. So that's a strike. So 2 more strikes. And unfortunately, I'm going to have to cut this series short. I probably won't seek a refund for this book, but I'll just move on to the next one. Python built-in types. Python implements dynamic typing or duck typing and tries to automatically determine the object's type as you declare them. Python has several standard types built into the interpreter: numerics, int, float, complex, and bool, the subclass of int with a true or false value. The other thing I forgot to mention that this book, and this is just for this doesn't earn it another strike. This is just part of that first strike. Is it said that CPython is the most common interpreter shell. I think most people use Jupyter or IPython or something like that. So this book just doesn't know about those things, and those things are typically what you're going to see more of, especially for somebody mastering Python. Sequences: string, list, tuple, and range. Mappings: dictionary. Sets: set and frozen set. None: the null object. The none type. The none type denotes an object with no value. The none type is returned in functions that do not explicitly return anything. The none type is also used in function arguments to error out if the caller does not pass in an actual value. Numerics. Python numeric objects are basically numbers, with the exception of booleans. The numeric types of int, long, float, and complex are all signed, meaning they can be positive or negative. A boolean is a subclass of the integer, which can be 1 or 2 values, 1 for true and 0 for false. In practice, we are almost always testing booleans with true or false instead of the numerics 1 and 0. The rest of the numeric types are differentiated by how precisely they can represent the number. In Python 3, int does not have a maximum size, while in Python 2, int are whole numbers with a limited range. Floats are numbers using the double precision representation, 64-bit on the machine, which is a horrible way to describe floats. Especially if they're trying to talk to beginners, as they seem like they are, even though it's titled Mastering. So, sequences. Sequences are ordered sets of objects in an index of non-negative integers. In this and the next few sections, we will use the interactive interpreter to illustrate the different types. Please feel free to type along on your own computer. Sometimes it surprises people that a string is actually a sequence type. So that's good. I'm glad they brought that up. But if you look closely, strings are a series of characters put together. Characters are enclosed by either single, double, or triple quotes. Note, in the following examples, the quotes have to match, and triple quotes allow the string to span different lines. All right, so let's do this. So A equals networking is fun. B equals DevOps is fun too. And C equals what about coding? And then on another line, we're going to say super fun. One thing to note, you might think, oh, well, why do you need 3 different ways of having strings? Well, you know, for C, it's obvious why, because if we were to say D equals networking, and then on another line try to say the is fun, we've got a syntax error because we were using single quotes. So triple quotes are about being able to type across multiple lines. But why do we need the option of double quotes versus single quotes? Well, what if I say D equals, and I were to use single quotes? Don't you think, come on, this is fun? You know, now it's ambiguous about where I'm closing that string. So I can just use double quotes, and then I can have that single quote in there, and everything is just fine. Same thing for if I had double quotes in here. So I can say my favorite, so D equals, if I were to use double quotes, and I would say my favorite character is the character. Same issue. So we need some way of defining these strings to where we can not worry about whether we're using the kinds of characters that we're using. Another thing you can do is escape it. So if you add this, then you're saying these special properties of that character don't apply. It's just a character within this string. It doesn't, the extra features of the quote starting or ending a string do not apply because they've been escaped out of using that escape character. The other 2 commonly used sequence types are lists and tuples. Lists are a sequence of arbitrary objects. Lists can be created by enclosing objects in square brackets. Just like strings, lists are indexed by non-zero integers that start at 0. The values of a list are retrieved by referencing the index number. So vendors equal Cisco, Arista, Juniper. So here's what they mean by values of a list are retrieved by entering the index number. So lists are always indexed from left to right, starting with 0. So the value at index 0 of this list vendors is going to be Cisco. At index 1, it's going to be Arista. Index 2 is going to be Juniper. If you want to return back the value of multiple indexes, let's say we want index 1 and 2, you can use this colon character. At what? Oh, sorry. You can use this colon character, but it returns back a range up to, but not including the last one you specified. So we only got one result back because we started at the 0 index and we wanted the 0 index, and then we wanted a range up to the first index, but not including the first index. So we only got the 0 index. But if we include a range up to, but not including the second index here, now we get 2. And we can do up to, but not including the third index. Now we get all 3. Up to, not including the fourth. You know, there aren't any I need to show. We don't get an error saying that we're having an index error, which is good to know. I actually thought that's what would happen. And that actually makes things easier, not getting that error there. But yeah, you can see how that works. You can also use negative indexes to get the final one. That's really useful, because if you don't know when this is going to grow, you don't know the length of it, you don't know what's going to be there, but you know that the one you want is at the very end of the list, but you just don't know how many are going to be in the list. That makes it so that you can get that. Of course, another way you could do that is just say the length of the list 3. So I can do vendors length of vendors. Oh, and then you've got to do -1 because it starts at 0. But that's another way you can do that. Instead of having to do that whole nightmare mess, you can just use a negative index. All right. Vendors 2, Juniper. Tuples are similar to lists created by enclosing values in parentheses. Like lists, the values in the tuple are retrieved by referencing its index number. Unlike lists, the values cannot be modified after creation. So let's continue this, and I'll speak more on this too. All right, data centers equal SJC1, X1, SF01. So just like lists, there we go. I think we still have those indexing powers with tuples as well. Yep. But you can see we've got parentheses instead of brackets. But you could see if we say data centers, if we do a help, this is not worth having a strike against this book, but if you do the help, you can see everything you can do. So all you can do is count and then return back the index of a value in a tuple. You can see in a list, vendors here is a list. Since it's mutable, you get all sorts of extra things you can do. You can remove items from the list. You can insert new items into the list. You can sort the list. You can reverse the list. Because it's mutable, you can do all those things. An immutable object like a tuple, you cannot. Some operations are common to all sequence types, such as returning an element by indexing as well as slicing. So here's our networking is fun. So strings are basically like lists, very similar. Here we got the E back because that's, if this were a list with every character individual, we would get back what was at the position, including a space. So a space is its own character, and it's shown there. White space is a character. All right, so now here's another one for vendors. So vendors 1, we're going to get Arista. Data centers. Yep, so LX1, and then A, the networking is fun. So we got that same indexing. There we go. And this is already what I did. I mean, this is really powerful. Like, I use this sort of thing all the time in the coding that I do. Remember that the index starts at 0, therefore the index of 1 is actually the second element in the sequence. There are also common functions that can be applied to sequence types, such as checking the number of elements and the minimum and maximum values. So let's check the length of A. Got 17. It's length of vendors. Got 3 in the list. Length of data centers, 3. So let's define a new list. And these are going to be integers. So let's find the smallest in the list. That's going to be 1. Let's find the biggest in the list. It's going to be 2. So if we want to see what we can do, like where did that min and max come from, we can do a help. We can see, we actually can't see where the min and max came from. That's interesting. I thought we could. Oh, so in order to do that, you'd have to do a help like that, and then you'd have to do I think no, it's not a module. I think it's built in is the word. But this is good to know too, because it shows you all of those libraries that you have available already. You can see it takes a while for it to tell you that. But let's do a help and then do built-in. Let's see here. How about topics? Here we go. So let's look at let's look at ints. So yeah, let's look at types, because that'll probably show. I'm surprised integers is, it is integer. Yeah, so here we've got an even better page than was in that book that we were just reading. So absolutely take a look at the help, get comfortable using the help, just like we saw on you know, it's apparent how useful this is. Fortunately, I don't see any help on that. Yeah, I don't see the max. Now I'm surprised I don't see that max. That's interesting. Let me take a look at help on the max specific. Yeah, max. So, yeah, because I'm always kind of a fan of, okay, you can show me something, but I'm not as interested in what you're showing me. I'm more interested in how you know what you're showing me, because, you know, teach a man to fish, that sort of thing. It will come as no surprise that there are various methods that apply only to strings. It is worth noting that these methods do not modify the underlying string data itself, and always return a new string. In short, mutable objects, for example, lists and dictionaries, can be changed after they have been created, and an immutable object, for example, strings, cannot. If you want to use the new value, you will need to catch the return value and assign it to a variable. So here we've got our good old classic, why can't I, okay, now I'm back. So yeah, so we still got that defined. This is our string. So so yep, here's one thing you can do. You can capitalize the first letter in the string. You can turn the whole string into uppercase. What else can you do? And again, let me drive the point home because this book, it might be worth a strike. I think it just falls into the first strike. I'm hoping there's good stuff coming later because I'm really disappointed in this book so far enough to give it a strike. And if I give it 2 more, I'm going to move on from it. But one thing I'm going to drive home, because this is a channel that I'm going to post publicly on the 25th, is that this help menu is just the most important thing ever. If you want to see, how did I know to use capitalize? How did I know to use upper? Well, it's the help. And unfortunately, there are, yeah, CCC, so use help for help on the string class. So it's a string, but there's no help found for this particular string. I was actually looking for help on strings in general, so I've got to say help string to get that. So now I can see capitalize and an explanation of it. I can see upper is on here too. There's just a lot of things you can do with strings. So here it is at the end. So that, I think, is the most valuable thing you can learn in Python is how to use that help and be really comfortable with that help. Because there's a lot of situations where, yeah, you can context switch over to the browser, you can Google it, you can read Stack Overflow, but sometimes it's just a matter of, oh, I forget how to make everything uppercase. Is it uppercase? Is it case up? What is it? Help? Oh, I see. Okay, it's just upper. All right. So, yep, and let's keep going on this. So I'll have to shrink this down a little bit. Perfect. Actually, not perfect. I want to shrink it down and I want to move it up. There we go. Perfect. So B equals A dot upper. So now we've got B equaling networking is fun. Does B equal A? No, B is something else. It's false that B will equal A. So the other thing we can do is split. This is really important for IP addresses because it breaks it up into a list, and you can specify what character to use to break it up. Here, by default, it just uses white space. So you can see the original A is not modified by that. It's just it's just the result of that method on the class. It's a string class. All right, so A, networking is fun. Let's do B equals A dot split. So, and then print out B, networking is fun. Here are some of the common methods for a list. The Python list data type is a very useful structure in terms of putting multiple items together and iterating through them one at a time. For example, we can make a list of data center spine switches and apply the same access list to them all by iterating through them one by one. Since a list's value can be modified after creation, unlike tuples, we can also expand and contract the existing list as we move along the program. And again, maybe you can do that, but that is definitely not something everyone can do. It really depends on the kind of environment you are in and how they handle this kind of development. If they have cultural problems, you won't be able to just run Python against data center spine switches. And even if they don't have cultural problems, they'll want you to be pretty good at Python before you get to do something like that. Kind of the highlighted area, when you first start, you're going to be doing things that are read-only and that obviously have value. But even then, you might have a hard time. Okay, but here's the append. So we added a new one on there. We can do that to a list. We can't do it to a tuple because because that's the difference between mutable and immutable. A better word is changeable, unchangeable. Mutable is just not a common word that people use. Changeable is a word people are really familiar with. Maybe in Deutschland or maybe Guido, he's a Dutch guy, maybe mutable is a more common word there than change is. All right, so there we got it with the R6 added to the end. So routers.insert, it's going to insert it after that index. So index 2 is going to be 0, 1, 2. So it's going to be between R3 and R4. Oh, sorry, before that index. So that's something I had wrong. I typically don't use insert very often. I typically only need to append something to the list. There's really not generally a reason you need to insert it at a certain index. All right, so, and then, yeah, so it's going to do it before the index. So then routers.pop, now you're going to pop a value at the specified index. So we're going to be popping R2. Routers, because that's at the first index. Pop means you're just going to remove it out. So if we look at routers again, this is a mutable object. It's changeable. So we have changed the object by popping it, just as we changed it by inserting and appending. So now it's missing this element now. Python list data is great for storing data, but it is a bit tricky at times to keep track of data if we need to reference them by location. We will take a look at Python mapping types next. Mapping. Python provides one mapping type called the dictionary. The dictionary is what I think of as a poor man's database because it contains objects that can be indexed by keys. This is often referred to as the associated array or hashing table in other programming languages. If you have used any of the dictionary-like objects in other languages, you will know that this is a powerful type because you can refer to the object with a human readable key. This key, instead of just a list of items, will make more sense for the poor guy who is trying to maintain and troubleshoot the code. That guy could be you only a few months after you wrote the code and were troubleshooting at 2 a.m. The object in the dictionary value can also be another data type, such as a list. As we have used square brackets for lists and round braces for tuples, we can use curly braces to create a dictionary. Dictionaries are one of the most common data types in Python. There is something really interesting about dictionaries, though, that I will explain. Unfortunately, this book hasn't explained. I'm kind of upset about that. It is if it's truly meant to be a beginner's book, I'm really kind of upset that they didn't bring this up. But this is not worth another strike. This will just kind of fall into that first strike. But this book definitely, I believe, deserves a strike against it for not mentioning what I'm about to mention after I finish this exercise. Okay, so the Python dictionary is one of my favorite data containers to use in my network scripts. There are other data containers that can come in handy. Set is one of them. So before moving on, hey, what gives, man? We learned about data types that are mutable. We learned about data types that are unmutable. Well, are you seriously going to introduce me dictionaries and not tell me whether it's mutable or unmutable? How rude. Is it a mutable data type like a list? Well, that kind of seems like it is. I mean, you can define a new key. We show that there. It's got to be mutable. I think it's a mutable data type. Is it so? But the thing is, you would be that wouldn't be exactly right. So it's a mapping type. It's not a immutable. So it's not a sequence. So it's a different thing. It's a dictionary. It's not a list or a tuple. So one thing you'll see that a dictionary has, so if I do a help on data center, one, I've got this thing copy here. Now, if I do a help on a list, okay, I do have it on list as well. Now, this is something I'm honestly not, this is something I learned about this month or a few months ago. And but here you can see we don't have copy since it's mutable. So one of the issues you can have is you send a list into a function, or you use a list somewhere else, you make a change to the list, and then you expect that change to have not persisted where you used it earlier in the code, because how can it go back and make that change if it didn't, if it's you're making it at a different time? Does it go back and run the code again, where I had it before? No, it's because I would say it is a mutable data type. I'm not sure about that, but if you want to make a change to the list, or you want to just put it in somewhere but not have it changed everywhere in the code, you've got to send a copy of it, because if you send the whole thing, you'll change the whole thing. So mutable data types, you'll often see have the ability to make a shallow copy. So if I want to say, if I want to do a function, so def change list, and then we'll have a list in there, and it's going to be list dot append changed, and then return list, and I make a test list, and now I do change list test. Now, if I print out test, I changed test. So what if I didn't want to do that? What if I only wanted to change the list I passed it in for the purposes of this function, but outside of the function, I wanted the list to be in its original form. So, there's a number of things I could do, of course. I could just say, test for func equals, so here's where it gets really interesting. So test for func equals test. Now what's going to happen to test? So let's do change list test for func. Now let's print out test. So test changed too. And that's because when we say that something is equal to that thing, we're saying it's equal to that thing. So test for function is test. So if I change test for function, I'm also changing test. So what do? How can I even make it so that if I send this through a function, I have the function only change this for the purpose of the function, but don't change it everywhere in the code? Well, that's where that copy is so important. So I can do test.copy, and now I get back my list test with the changed, but when I print out test, it's the original one. So that's really important. That's something that will guarantee you destroy you at some point when you're working on this. It destroyed me pretty hard for a while. I even brought in coworkers that were really experienced with Python, perhaps even better than me at it, and it stumped them too. One coworker, thankfully, eventually figured it out and let me know, but it wasn't just an instant, oh, I know what the problem is. It was like, oh, let me think. And then eventually he had to get back to me later. I mean, he kind of caught it like right away. It was like, oh, I think it's this thing, but I can't exactly tell you right now. But this is something that's really not, I think, well known. And unfortunately, it's because books like these don't point it out. So, but this is definitely a way you can get in trouble and not know how to get the result you want out of your code. So, so that .copy method that you show up in the help, if you ever see that there when you do a help on your data type, and you want to do something with that temporarily, but not change it for the whole thing, you better use it. Otherwise, you're gonna end up with a problem. All right, here are some of the common methods for a list. The Python list data type is a very useful structure in terms of putting multiple items together and iterating through them one at a time. For example, we can make a list of data center spine switches and apply the same access list to all of them by iterating through them one by one. Since a list value can be modified after creation, unlike tuples, we can also expand and contract the existing list as we move along the program. So I'm not sure if I did this yet or not. I do think I read that for the second time. I read it before. Let's just look at what router is. Okay, it's not defined. Oh, routers. Okay, so we got to redefine routers. And I think oh, right, okay. I went back to look at another section. So, yeah, so this is where I ended off sets. Sets. A set is used to contain an unordered collection of objects. Unlike lists and tuples, sets are unordered and cannot be indexed by numbers, but there is one character that makes sets stand out as useful. The elements of a set are never duplicated. Imagine you have a list of IPs that you need to put in an access list. The only problem in this list of IPs is that they are full of duplicates. Now think of how many lines of code you would use to loop through the list of IPs to sort out unique items, one at a time. However, the built-in set type would allow you to eliminate the duplicate entries with just one line of code. To be honest, I do not use the Python set data type that much, but when I need it, I'm always thankful it exists. Once the set or sets are created, they can be compared with each other using the union, intersection, and differences. And I use sets a lot. A good example is if you need to pull a bunch of host names, you're worried about having duplicates or something like that, you can always use set, look at the length of your set compared to the length of your list, and you can see how many duplicates you had, or how many total were duplicate entries. All right, so let's learn about a set. All right, so you could see an L was removed because sets only contain unique elements, and A in this case equals the word hello, which has an L twice. So the set will only list it once. You also notice that their set says HLOE, mine says HOEL. That's because sets do not have a specific order. The order is, I don't know if it's completely random or whatever, but it's not going to be the same every time. It just depends on your own environment and stuff. It will depend on which computer you use. Depends on the orders of the set that are returned. There's no built-in ordering mechanism like there is for lists and tuples, where when I define a list or a tuple, it's going to be the same order as when you define a list or a tuple. That's not true for sets. And I'm saying not when I, hopefully that's clear. Obviously, when I define a set, well, the order won't be the same in a set as it will be in a list or a tuple. Or the property of a the property of the order of a set is not the same as the property of the order of a list or tuple. So here we can see we added 5. Again, where this book is falling short, but not worth a strike, I think, is it's not telling you how to use help to go and see where that .add came from. So add element to a set. This has no effect if the element is already present, because then you'd be adding a duplicate, and sets are all unique. Every element in a set is unique. Okay, let's see what the difference between add and update is. So add is to add an element to the set, but what is update? Oh, okay. Yeah, I don't see update anywhere, but the book says it'll work. Let's try it. Okay. So another kind of aside is, as was mentioned in this book, one of the main advantages of Python is that import statements, because you can bring in a bunch of libraries that make things easier on you, where you don't have to reinvent the wheel. You can just use tools that were already created by people presumably smarter than yourself. If that's not true, then by all means, make your own tool that's better and get it a part of the standard Python library, please. But one of those tools is called Pandas, and it's a tool where things like making everything unique, like you would use with a set, is a little bit easier to do. I unfortunately have not used Pandas a lot, but I know people who have and really will kind of tout it as a key pillar library for Python that everyone must know. So I don't know what this, what they mean by 1 star. I mean, that's obviously not a valid thing you can do in Python. It's just do a 1 star. I don't think it's worth a downvote, but it is pretty upsetting. And I don't mean a downvote. I mean, I don't think it's worth tossing the book aside and either working on a new book or going through a GNS tutorials or a course that I have. I think we can still work on this. All right, Python operators. Python has some numeric operators that you would expect, such as plus, minus, and so on. Note that the truncating division // also known as floor division, truncates the result to an integer and a floating point and returns the integer value. The modulo %sign operator returns the remainder value in the division. So let's do these exercises. 1 + 2 is 3. At least that's what you'd think. If you watch the White House, you might have a different opinion about that. But thankfully, that is why opinions are opinions and facts are facts. Yeah, so 5 divided by 1, we get 5.0, but we just get 5 if we use that. There are also comparison operators. Note the double equals sign for comparison and a single equals sign for variable assignment. So we're going to see if A equals B. It does not. We're going to see if A is greater than B. A is 1, B is 2, so it does not. Is 1 less than 2? Yes, it is. Is A less than or equal to B? Yes, it is less than B. We can also use 2 of the common membership operators to see whether an object is in a sequence type. Aha, and this one, this is really essential. This I use all the time. So, and it's not just to see if it's a part of a string. It can be a part of a list. It can be anything. So I'll do that. So A equals hello world. So Is there an H in A? Yeah, it's the first one. True. Is there a Z in A? Well, I don't see hello world having a Z, so false. Is there an H that is not in A? Like does this hello world not contain an H? False, it has an H, it's the first character. What about Z? Is that not in hello world? Yeah, I mean, I don't see it. It's true. There's no Z in this A, which is the string hello space world. The Python operators allow us to perform simple operations efficiently. In the next section, we will take a look at how we can use control flows to repeat these operations. And let me go into more depth and detail about this, this in word. So I'm going to do a test here. And it's going to be, we'll say 1, 2, 3. And now is 1 in test? Yeah, 1 is in test. What about 4? Nope, 4 is not in test. So even though it's a list and it's not a string, you've got that same capability, but now it's going to be for the element and not for the particular character. So if I had a list that was hello, and then on the second element it was a space, and then the third element it was world, so it looks very similar to what we have for the string, right? So there's going to be an H in this, right? Because that's what's in the string, right? Oh, and I forgot the quotes there, so it thinks it's a variable. So that's a good lesson. One thing, just kind of an aside, the more you see of these and you're learning Python, the better you are. You want to see those because you want to get used to what the errors are. You want to be comfortable seeing an error. The worst case scenario you can be in working with Python is to see an error and be saying to yourself, what the hell is that? I've never seen that before. You want to be familiar with all those errors. You want to know why those are triggered, and you want to know how to either avoid them or handle them. The error tracing in Python is, I think, one of the best features of Python. Most of the errors you get back are very useful once you become at a more advanced level with Python. Even at an intermediate level, I would say error messaging is a huge advantage that you can get through using Python as opposed to a different kind of language. So, but let's think about this some more. So here's our list. It's going to be just like our string, but our string A. So we know that, of course, there's going to be H in A. It's the first character. But in test, we've got an H in test too, right? Of course we do. I mean, it's right there, right? So just like it was in here, it's going to be in there, right? Wrong. We don't have this character or this whole thing. We don't have that in test. We have this whole thing in test. We have this whole thing in test. And we have this whole thing in test. But this whole thing, no, we don't have that in tests. We have it as a part of the first element in test. So is it going to be here? Yeah, of course we do. In the first element, yeah, we've got an H there. But do we have an H in the list test? Well, no, we don't. Do we have hello, the whole thing in test? Yeah, it's right there. What about hell without the O? Do we have that? No, we don't have that. We have hello. Now do we have hell in the first element? Where is the string hello? Of course we do. It's right there. We have it in this first element. It's there. But do we have it in this whole list? No, we don't. We have hello. We have a white space. and we have world. So that's another really important thing to know, that unfortunately this book has failed at teaching, but it's not worth another strike. And you get the added bonus, whoever might be watching this, of learning this now. So that's a really important thing to learn. That's thing the authors of this book might not even know. But it's another thing that will absolutely demolish you in the middle of your project. Whatever you're trying to do, you don't understand this concept, and you try to use if statements, your project is not going to go well. You're going to have a lot of problems. So, okay, so moving on. Python control flow tools. The if, else, and elif statements control conditional code execution. Unlike some other programming languages, Python uses indentation to structure the blocks. As one would expect, the format of the conditional statement is as follows. If expression, do something. Elif expression, do something if that expression meets elif expression. Do something if that expression beats. Okay, that's not very, I don't like that, not worth a strike though. Else statement. Here's a simple example, so let's check that out. Yeah, this book I'm kind of unhappy with. I actually did give it a strike, meaning that if I give it 3 strikes, I'm just gonna stop. You can see, I'm only at location 860, and I've got to get through the whole book. So I'll save myself a lot of time and effort if I just decide, you know what, this book doesn't really have anything to teach me. I have another book that does, and I have a GNS course that I know will, because I've done it before, and most of what I have done on the job that has been effective have been using the code examples from that course. The other thing I can do, which I'll probably, that's what I'll do, is I'll just get more confident using the Kirk Byers libraries too, because those are, the course I did on GNS was made by somebody at about the same time as Kirk Byers. So they, were a little bit of a learner themselves. But they they actually did not have like the stuff Kirk Byers is doing is next level, really amazing stuff. All right, so A is large than 9, so you can see it is what I typed there. It's not some pre-recorded message. The while loop will continue to execute until the condition is false. So be careful with this one if you don't want to continue to execute and crash your process. While expression, do something. So let's learn about while loops. Yeah, and I don't have anything more to add to the if-else statements. They're all pretty self-explanatory, simple logic stuff. So you won't really see this going on in the well, let's stay on topic here and not make snide remarks about what's going on at large in the world right now on May 1st. I'll tell you it's a lot, May 1st, 2020. But yeah, so let's just keep focused. And actually, this might be a good sign that I'm going to need a break eventually, kind of having trouble maintaining focus. So I'm going to try to go until either 5:30 or until I finish this chapter. But I don't have anything more to add to these conditionals. They're really self-explanatory. I think there is a finally. So if, so I'll run this again. I think there's a finally. So if a Oh, there is no, oh, well, I accidentally ruined the whole thing by using a quote instead of a, but yeah, you can probably get help. So if I type in topics, conditional. So yeah, we can get help on the conditional, and this is going to be, so yeah, I don't see a finally there. So, but this is going to be as good of a help topic as here. So all we got is if, elif, and else. Whoops. Okay. So moving on. Oh yeah, and I already read that. So we're going to be just typing in the code a equals 10, which for some reason. Okay, now we're good. Okay, so we're learning about while loops. B equals 1, while B is less than A, print B. And now here's the key. If you don't increase A, or sorry, if you don't increase B, B is always going to be less than A no matter what you do. If you don't include this line here, B plus equals 1, you won't be incrementing B, and B will never be greater than or equal to A. So this while condition will never evaluate to false. It will always evaluate to true because 1 is always going to be equal to 10 unless you increment B, and now you're comparing 2. Is 2 less than 10? Is 3 less than 10? And then you get to 10. 10 is not less than 10. It's equal to 10. And your code will stop because this will be false, be no longer true. And even though B equals 10 now, you're not going to execute the next iteration because the while conditional evaluated to false. So you'll only print up to 9. The for loop works with any other object that supports iteration. This means all the built-in sequence types, such as lists, tuples, and strings, can be used for a for loop. The letter I in the following for loop is an iterating value. So you can typically pick something that makes sense within the context of your code. For I in sequence, do something. So let's learn about for loops. I do have something extra to talk about when it comes to loops that I think is really important and really valuable for network engineering, especially for reading through show runs or command output or anything like that. But I will wait until the end of this exercise. Yep, so it's going to go for number in A, and number, this can be anything you want to be it. Part of Pythonic is being explicit instead of implicit, so you really want to say something here that is meaningful to the programmer because you're writing code for other people to read. So if you say for I in A, well, you know, that might be convenient for you, but what is I is just an index, like why are you using I? And then down here, if you print I, well, what is I? Here, print number. Oh, okay, you want me to print a number. So like if you have a list of devices, or let's say you have a list of Cisco devices, you can say for Cisco device and Cisco devices. Let's say you have a list of Juniper devices for Juniper device and Juniper devices, and you can have a clear, once you're going through, you have good information about what is happening in the code just at a glance without having to go back and read a bunch of extra code. Okay, so we're going to print all of them here because for number in I, so first index, second index, third index, fourth index, or every index one by one prints the index. So Okay, so now that we have taken a look at Python data types, operators, and control flows, we are ready to group them together into reusable code pieces called functions. But before we do that, there's something I really like to do in Python, and that is, so let's reset A, because right now A equals 10, or sorry, let's reset B, because right now B equals 10. So B is going to equal 1 again, and then we're going to do while B is less than A, we're going to be printing B, and now, of course, don't forget to increment that index, otherwise you will have a loop that never stops until it crashes your computer. I think there are usually mechanisms to detect that, oh, this loop is not meant to go for this long. But you'll save yourself some hassle by just remembering to do it right the first time. But what I wanted to add to this section was that just like you can do an else in the conditionals, if A equals B, print A, else, you can do an else in while and for loops. And else is a really bad word in this context. I wish they would just have a new word called after, because after describes what's actually happening. So while A is less than B, in a loop, go and print B. And then increment that B, and now when this evaluates to false, so it kind of makes sense why they used else, because just like an if depends on whether the conditional is true or false, a while depends on whether it is true or false. So if it's false, that's when you're going to trigger the else. So it does make sense that it's the same keyword else, whether it's a while loop or an if statement, because it's still a conditional and you're still doing something if that conditional evaluates to false. But it makes more sense to think of it as if it were the word after, because you're going to do it after this loop is done. So, but unfortunately it is else, which is a little bit confusing. But with this, what you can do is you can say else the loop, or print loop complete. Oh, did I redefine A? Yeah, I did. Okay. So A no longer equals 10. A I redefined to be a list. So let's redefine A back to 10, and then B back to 1. And then let's do this loop while B is less than A. We're going to print B. Then we're going to increment B. We're going to do else print loop complete. And yeah, so you can see now that it's done, it's going to print that loop complete, which can be really valuable, and I will show you why. So we're going to do print B. We're going to do if B equals 5. We're going to do a break. And then we're going to do B plus equals 1. And then we're going to do a else print loop complete. So oh, right, and we never reset B. So you can see we never reset B. So this is only going to be triggered if this statement here evaluates to false. This is what I'm trying to demonstrate right now. So if we have a situation where this never evaluates to false, for example, like if we check if B is a certain value, and then if it is that value, we're going to just use this keyword break to stop the loop instead of going back and reevaluating that conditional, B being less than A. now we won't hit that else statement because that conditional that determines whether or not the while loop goes to the next iteration never hit false. It was broken out of that loop before it had the chance to evaluate that conditional an additional time. And every time that conditional was evaluated, it was true, which means it doesn't trigger that else statement. It's only triggered when that conditional is false. But the reason that's really important is, so back here, our original example, so A equals 10, B equals 1, while B is less than A, print B, and then B plus equals 1. So this whole thing, we can see, oh, well, I wanted it to print B, like, you know, it incremented it to 1, but, you know, yeah, B is no longer less than A. So yeah, I want the code to stop now, but I wanted it to print out B again because B is going to be equal 10 now. So that's something you can do, is you can add that else statement, and then you can do whatever you wanted it to do after evaluating false for the first time. But for me, the most important thing is if I have a output from a networking device, so it's like interface GE01 or GI 0/1, and then I have switch port mode trunk, switch port trunk allowed VLAN 100, 200, and then I have no shutdown, and then I have a character signifying the end of that section of my show running config. What I can do is say while sorry, I can have example. Now I can split this into a list. Based on a new line. So now example list is going to be all on new lines. Now I can go through this in a for loop and say, or sorry, in a for loop or an example or a while loop. It doesn't matter. I'm going to do it in a for loop. I'm going to say for statement in example list. And actually, I've got to do line number. So I'm kind of introducing a lot of things at once, which is kind of unfortunate for somebody intending to look at this as a learning for the first time thing. But this is not my intention. I'm intending to prepare myself for a new job I'm starting on the 25th of this month. So I just want to get used to doing this. So for line number statement in enumerate 1, I can say if statement equals this explanation point here, you know, I know what my output's going to look like. I know what I'm looking for. So basically all I want to see is what's the line above this going to be, or what's this whole thing going to be. So if statement equals, oh no, I do have to use a while loop for this. I remember what I was doing. I'm actually going to come back to that later. For now, let's see how much more I have to read in this chapter. Quite a bit. So yeah, I think I'm going to just bookmark this. And as I said earlier, I definitely need a break. This has been going on for like 2 hours. So thanks for watching, come along on the journey with me. Yeah, next video I'm going to be going over Python functions, and I'm going to be hopefully having a better explanation for how I would use those while loops with except statements to read through a show run. That's going to be really valuable for me to have a understanding of how I used to do that, so that I'm ready to go on day one of the new job. So thanks for watching. Stay tuned for more.